Welcome everyone to Mastering Data Management, Leveraging FME for Cloud Native Databases. So today I am joined by Steve and Trent. So I'll hand the floor over to Steve to introduce himself.
Good morning, good afternoon, good evening, depending on where you're at. Thanks for joining us today. I'm Steve McCabe. I've been with SAFE for, like I was just saying, about 12 and a half years now. It's been a blast. I work predominantly on the FME flow support team, but I do a lot of stuff in databases. And I guess it's over to you, Trent.
Yeah, hi, Trent Kading. I've been with SAFE for about 6 years on the forum support team, and I kind of do a lot of utilities and database support.
Excellent. And we're also joined today by Nampreet, who's helping us on the back end with Q&A. So thanks so much to Nampreet. All right, so just a quick overview of our agenda. First, we're going to go through a brief introduction to the topic and FME for those who are newer. Then we'll dive into FME and cloud native databases, optimizing your workflow efficiency, deploying FME in cloud environments before we move on to best practices for managing your big data using FME. And then we have a real world example to share of migrating 150 million records. We'll also have a live Q&A session. So if you do have any questions throughout, please do use that questions panel on the bottom right. As I mentioned, we have Nampreet on the back end helping us there. And we have the chat as well. So keep letting us know where you're tuning in from and how many years you have used FME for. We also have a couple polls coming up. So use that, keep an eye on that polls tab for those. Share your emoji reactions with us throughout the webinar as well using that react button. Lovely. And if you have any audio issues, click the help button on the bottom left for 4 simple troubleshooting steps. All right, if you would like to download the slide deck and follow along, you can click the button on the top right of the PDF there as well. And with that, I will hand things back to Trent as we have a poll here that I'll launch.
Yeah, so just to start off with a question, we're kind of curious, which cloud databases are you working with?
Perfect, and you should see that now in the polls tab. Yeah, and if you don't see a cloud database that you work with there, please do chat it out in the chat panel.
I see a lot of Azure SQL Server, it looks like. A few Snowflake.
Yeah, so Azure SQL Server seems to be the big one here today. About 70%. Mm-hmm. Snowflake, Oracle.
I'm curious about the others as well. So hopefully there's a few that are willing to share on the others.
Looks like DynamoDB is the only other right now. Awesome. Thanks so much, everyone. We'll keep an eye on that, but thank you for sharing.
Okay, as we go on, let's get started.
Definitely. And before we move on to introduction, I'll just get our presenters to turn off our webcams just so we can save on some bandwidth here for the remainder.
Okay, so the goal of today's webinar is hopefully we're going to help you, effectively manage and optimize your big data workflows, especially when working with cloud native databases within FME. So the big one that we're going to focus on is kind of operational efficiency, if you will. So now we'll just do a quick flash demo. Just share my screen. And share. So I'm not going to run any of the workspaces. I'm just going to kind of step through them briefly. So on this one, the goal of the workspace is essentially just to read and write 5 million features to Snowflake. I ran this earlier this morning, and I was able to read and write 5 million features to Snowflake within just over a minute. And the goal of the workspace here is so we're reading a CSV, and I'm just writing it, just for the sake of creating a CSV as well. I do a little bit of attribute cleanup. I'm truncating the existing table that I already have. I'm then publishing that CSV file that I've created earlier to an S3 bucket, and then I'm using Snowflake's native tools to essentially import or ingest that CSV file from the S3 bucket directly into the table. Now, continuing on. So again, the whole point of this webinar is we really want to help you improve your cloud database experience when working with FME. We hear, customers often aren't entirely sure what the differences are between on-prem versus cloud when it comes to working with FME. So kind of just to name a few. So one, data integration complexity can be quite different between an on-premise versus a cloud. Security is a big one. On-prem, it's behind your firewall generally. There's no outside access, whereas cloud can be accessed from anywhere. Performance, on-prem, you're generally directly beside your database, so performance can, in most cases, is never really an issue. Whereas as soon as you move to cloud and you can access that database anywhere, performance, whether it be on the database side, network latency, can really become apparent and really bog down a workflow. And then a lack of best practices. What works on-prem might not work on cloud, and vice versa. So we're really hoping to let you walk away with some best practices at the end of this webinar. So if you're new to FME, just a little bit of background here. So we've been around for around 30 years. We have customers all over the world. And if you're completely new to FME, so it's an enterprise integration platform with essentially two applications. So we have FME Form there on the left, which is used to build and run the data workflows as kind of your authoring environment, if you think of it like that. And then we have FME Flow or FME Flow Hosted, which is where kind of the automation side comes across, really where you can kind of take your workflows to an enterprise level. Now, over the years, we've responded to our customers' needs, and we now support over 400 formats, standards, and applications. You'll see we supported GIS and databases in the late 90s and early 2000s, and we've just kind of expanded and kept up with the growth and new initiatives when it comes to moving into the cloud. Now, here's just a few of the cloud databases we support. Oracle, Azure SQL Server. I saw a couple people mention about that. Snowflake. And these are just to name a few. Continuing on. Now, here we have another demo. So in this one, what I'm going to be doing is reading and writing to MongoDB. Now this one, this workspace, you'll see it looks a little simpler. So what I'm doing is I'm just reading a CSV file and just writing straight to Mongo. Now there are in this scenario works perfectly, but there are alternatives that you could explore that unfortunately we just ran out of time in terms of trying to get set up. Is you could try writing to a JSON file or using that CSV file and using Mongo's tools to directly import that table as well. And the same would go for reading as well. If you wanted to read from Mongo, it might be faster to export to a CSV or a JSON file and read into FME that way. So now the importance of cloud databases. So one, they're purpose built for the cloud. So it leaves behind all constraints of an on-premise database. Two, storage capacity. They're far more fluid. Scalability, with it being in the cloud, it's far more agile in terms of being able to scale on the fly. Access, I mentioned this earlier. On-prem, you're kind of limited to being, behind your network in order to access your database. Whereas when it's in the cloud, you can kind of access it anywhere, whether it be through a data portal for a large audience or stakeholder, or just being able to, if you're a DBA, you need to do some work on the database, you don't have to be directly beside it or behind the network rather. Portability, so it's easy to replicate a database to other regions. If you need, say your current cloud database is on the West Coast, but you have some users that want to access it on the East Coast, you could just replicate a database environment over to the East Coast, should just reduce that database load. Risk management, this is a big one. Backups and recoveries and server redundancy are big things when it comes to cloud. I know we've at Safe have experienced firsthand of a database server dying and just, it's not recoverable or anything like that. Like the machine is basically just gone, and all that data, we never had a chance to back up because it was an on-premise database. And security, cloud databases are built with security in mind, and they're conscious from the ground up. So it allows for encryption, anything like that. And then lastly, cost reduction. Something I never thought about originally when it came to on-premise databases was the hardware. So a cloud database reduces costs in terms of operation with you don't need hardware renewals or patching efforts or anything like that. You don't need a separate storage container for the database. I know what, as I mentioned, I never thought of it before, but customers sometimes will mention that they're not able to upgrade their database because they just don't have the infrastructure to support that new version yet. Steve, did you want to chime in on anything there?
Yeah, no, I mean, the big thing for me is really down to just a lot of these environments are built from the ground up to be in that cloud environment. Security is at the paramount front of all of that. And you touched on that. So I think you covered off anything I wanted to add in there. So it's great.
Okay, so now we're going to really look at the optimizing of the workflow efficiency. So some techniques that you can use for maximizing FME's performance with big data, and especially with cloud databases, is, I can't reinforce this first one enough, is let the database do the work. The databases are made to handle this type of processing. And if it already has those native tools are going to be far superior to anything that FME can create out of the box. Think about your proximity to the data. So I mentioned before, if you have users on the East Coast and your cloud database is hosted on the West Coast, that is a significant network load that has to transfer essentially across the country in order to get those users the data they need to work with. So really, think about how close you are to the data in terms of a network. Be creative. This one is kind of an abstract one, if you will, in terms of, and what we mean by be creative is, don't be happy with the status quo. Think outside the box, because a workflow can consist of just a reader and a writer to your cloud databases, but there's there's other options that may be far superior in terms of performance. And we'll get into a couple of those later. And again, I'm going to harp on this throughout the entire webinar, is let the database do the work. So we have another demo. So this one is going to be reading from Snowflake, and this is where we'll really start to show, the letting the database do the work.
Okay, see your screen.
This one here. So this one, so I'm reading from a Snowflake table. It's got 150 million records in it. And what we're doing first is we're going to export that table to CSVs and store those CSVs on S3 in a bucket. Now, the reason doing this is it generally can be faster. CSV is one of the fastest formats to read in FME. And it reduces that network load kind of almost instantly, in terms of I don't have to wait for that Snowflake data to travel, a network within FME. So I'm using Snowflake's native tools just to export that CSV to S3. I'm then going to list the S3 files that I've loaded to that from Snowflake to that bucket. And then I'm going to download those files, and then I'm going to pass those files to a feature reader and just read those CSV files in. And then you can continue on with your workflow. Now, here's some results of doing that. So when I ran that workspace I just showed, so you'll see I've listed the source location. So that's where the Snowflake database is actually being hosted. And then the FME location is where I reside. And then the bucket location, if I used a bucket, was on the West Coast. So the first method, I just used a Snowflake reader, and I was able to read all 150 million features in about 49 minutes, roughly. Now, when I tried using the workflow that I just mentioned in terms of exporting that Snowflake table to CSV files that are hosted on a S3 bucket, I got 58 minutes when it was 300 files. And then within that, exporting the table to CSV files, you can essentially limit how large of a file you want each CSV file to be. So the default which is I think 16 megs a CSV file, it would create 300 CSVs. Whereas for my last option, I wanted to essentially break it down and let's see what happens if I write less files but the same amount of data. So I did 8 files, and I was able to read in about 41 minutes. And I'll touch on, this was not optimized by any means, in terms of the fact that if I really wanted to optimize this, the FME location would have also been on the West Coast. So I would have had a VM set next to Snowflake and next to the S3 bucket, and that would have most likely drastically improved performance times because it wouldn't have to travel that. I wouldn't be reading data and pushing data back and forth from an S3 bucket on the other side of the country.
And Trent, another question: is this were the CSV files compressed that were being created?
Yes, good touch on that. So yes, so the files that were created by Snowflake were compressed. I would imagine, I can't recall now, when I tried uncompressing them, that the files are drastically larger, and in my scenario, it would definitely hinder performance with the fact of me downloading from the S3 bucket to an East Coast.
Yeah, 100%. Great.
Now, some strategies to improve workflow efficiency and reduce the processing time. So, we really harped on letting the database do the work. So one thing that I see a lot of times on support is users writing directly to the database. When it comes to cloud, can you avoid doing that? And what I mean by that is does the database support importing an external, a third-party file format? Could be a CSV, it could be a Parquet file, something that the database will have native tools that it can import those files far quicker than FME sending batches of features to write. And the same goes for the exporting. Does the cloud database support exporting a table to a third party? Could be CSV, Parquet, GeoParquet, which just came out. Anything like that to basically reduce the essentially the database load, because the database will be able to export if it supports exporting or importing to a third-party format. That will be quicker than FME doing those batches of writes or reads from the database. Now jump into another demo here this one will be writing to Snowflake, and the real blocker here was performance. I wanted essentially to write to the database as fast as possible. So what we're going to do here is we're actually going to leverage the database to improve the writing performance, and this essentially will allow you to minimize the uptime or downtime of providing that new data to your customers or to your users. So what I'm doing here is, I'm assuming that my CSV files I've already created in another step of the workflow. So in which case, what I'm doing here is I'm just going to read the CSV file paths, in which case I had, in this instance when I ran it, I had those 300 CSV files. I'm going to upload those CSVs to an S3 bucket and then import those CSVs from the S3 directly to the table. And stop sharing, go back to the workflow, and we'll see the results. So this was writing 150 million records to Snowflake. The source location, the FME location, the bucket location are all the same as that previous example in terms of the Snowflake and the S3 bucket, both being on the West Coast and my FME being on the East Coast. So when I use the Snowflake writer, so just reading those CSV files and then writing them directly to Snowflake, it took about 4 hours and 40 minutes, give or take. Now,
just one thing about that workflow, our writer does compress the data behind and send it up as compressed CSV files. Is that correct?
Yes.
Pretty sure. Yeah. So.
Now the second workflow, which is really where I started to see the performance gain, was I used a CSV writer, and then wrote them as a compressed file, uploaded to the S3 connector, and then used some SQL to ingest that directly to the table. And that took about 11 minutes and 20 seconds. Now, the really fast one, which I was able to do with a workspace runner and really essentially batch the running, which is, you could even take that to another level with FME Flow, which we'll explore later on. writing compressed CSVs and then uploading them to S3 and then using that same SQL as 300 with 300 files batched. It took 1 minute and 22 seconds within FME, and then roughly another 8 minutes on the database side to finish the processing of loading those CSV files in.
And what's interesting to note here is just the fact that, you know, in the first process, when you did the 300 files, it took a little bit longer to get the files down than it did with the smaller or the bigger files, the fewer bigger files. They came down quicker. So two ends of the equation here, and we got different behaviors of what might be the most optimized thing to do. So I thought that was neat.
Yes, 100%. Yeah, it really shows that you really have to find the balance act between, you know, what works for writing might not work for reading and vice versa.
Yeah.
Over to you,
Okay.
Steve.
Yeah. All right. Thanks. So yeah. So next we're going to just touch on some, you know, the security concerns when working with FME and big data. Ultimately, a lot of people are very conscious these days about security. FME supports TLS and SSL connections to your databases. So that's just meaning your data is going to be encrypted in flight. So the other key thing you got to know is if you're reading from a database that you haven't configured for SSL connections, then you may be reading unencrypted data. And that's something you just need to be aware of. In case you do have a bit of sensitive data, where is it going to be going? So many of the database connections can be set up for SSL. So I recommend doing that when you're starting to move data to the cloud. And it's also possible in FME to do one-way TLS connections and two-way TLS connections. And what that means is one way is really just establishing a secure connection and encrypting your data in transit. But the two-way really says that the database knows who the client is. So if you're on some random machine, you're not going to be able to connect to that database. So it's always good to consider tightly securing your environments down. So the other topic would be around sensitive data. Again, I touched a little bit on that, but just basically be aware of the data you're moving and where it's going to be sitting around, right? So if you're coming from on-premise and it's not encrypted, well, that's one red flag. But then where is it going to be in the cloud? In the case of the demos that Trent just showed, we had some S3 buckets in play. You know, are they secure? Are they public endpoints? So making sure that you're putting them where you think you are, because you don't want anybody just to be able to pull some data down that they shouldn't have, right? And if you're new to FME, or sorry, if you're new to cloud environments and working with the platforms, this is an area where, you know, it's kind of hard to mess up. You really have to, by default, they're pretty locked down, and you really have to kind of open things up to get access to them. So, you know, your virtual private cloud networks and stuff like that from your on-premise environments are really going to be helping you secure that environment by default. But if you do end up opening up some things, you just got to be careful what you're opening up and what data is being exposed, especially the data that's sitting around not in a database. So data lingering, what I mean by that is really just being aware, again, where the data is going to be through the processing, right? So we talked about the sensitive data being accidentally put into an S3 bucket that might be publicly accessible, things like that. But also FME, is it using some staging locations somewhere on some servers or file servers that you may want to kind of clean up behind yourself as you finish migrating the data? So an FME can help you with that. You can automate that stuff so that you load a file in, you clean up behind yourself. Now, if it's FME itself that's doing some local data caching, not a problem. We're going to clean that up when the engine restarts. The temp files will just disappear and you won't have to worry about that. So again, the other last point I'll say is, where is your FME located? Is it in a secure environment? Could someone else be accessing that environment while you're doing these processes and that kind of stuff? So these are just kind of some of the security things that I think about in the cloud environment. And by no means is this the end of the list. There's going to be unique considerations for your environments and what you're doing within them to move data from one place to another. Okay, deploying FME in the cloud environments. I'm going to click on the next slide here. And we've got, obviously, FME, very versatile platform. and it can be distributed onto all of these environments. These are the well-known players in hand, but don't rule out, you know, your own data centers. We have customers that do have their own data centers that are geographically different than their main office. So there's users deploying FME into those environments. We have other lesser known data centers that customers are using where they have Windows or Linux OSs that are supported for FME to be installed on. So again, these are all kind of options that you can look at. There's really nothing holding you back from having FME in the cloud for you. And then if you're looking for something that's kind of managed for you, we have the FME Flow hosted. That sits on top of AWS cloud environment. And it's, you know, so if you are making use of other AWS services, then that's a really good winner. But also it does, you know, you can open up and connect to other cloud environments where you might have cloud databases or storage that you might want to interact with. So that's just a couple of the ideas there. And then, you know, integrating with, you know, your cloud platforms with big data, you really want to look at what you can do to optimize the workflow. So take advantage of the cloud platforms. These cloud platforms have lots of great things that you can utilize to speed up your workflow. For example, there's things that you can accelerate the data transfer from certain areas of your wide network that might be on the East Coast, get some acceleration for data file transfer so that it shows up faster in those West Coast environments. You also, in the virtual LAN, as you know, very well know these days, it's pretty easy to spin up a VM, couple CPUs, and realize, hey, I need 16 CPUs on there, or not enough RAM, or maybe you've accidentally created an image that's on standard storage versus premium and storage. Those little things, being aware of those and thinking about those as you go through this, are just things you're checking off to make sure you've dealt with them and understood them, because they can make a massive difference in a long-running process. You know, and without saying performance SSD drives, like there are differences across the platforms. There's still that premium storage that you'll want to look into. Okay, yeah, so ensuring that seamless connectivity and scalability when it comes to FME, understand how you can scale your FME engines. You know, if you come primarily from an FME form environment on the desktop environment, you may not think the way the FME flow environment can be scaled and work. So just think about your workflow. Are you really scaling it for your desktop environment, or are you scaling it for the server environment? Ensure that you have enough resources on the systems. Just really think about the you know, if the FME engines are hungry for CPU, make sure those CPUs are you know, kind of one CPU per engine. If you're heavy on the memory, just make sure you got enough memory. If you got 18 engines running at the same time and they're all taking, you know, 2 gigs of RAM, that's 36 gigs of RAM right there processing this big data. And you may only have a 32 gig assigned to it, right? So now you're fighting with cache space on the disk. So just think about what FME is also doing in this. Your network topology, really look at what Trent was talking about earlier, and that is getting that FME closer to your data. And it may not matter in some cases, but it may matter a lot in other cases. And that's kind of there's no real best answer to that, because we saw some interesting finds during our big data processing, and we've got a couple more demos coming up that we'll show you. But it really did make a significant difference. Virus scanners and file scanners. Oh my gosh, I don't know how many times I've been on a call with supporting a customer that's got some unknown problem, and it turns out it's a virus scanner, or, you know, port scanner even, not mentioned here, but, and then file scanners. Like, what's really happening behind the scenes there? Are you hogging some resources? Are you slowing down the performance of the workflow because you're deploying these? And you may not be able to get away from that, but if you know it and you can benchmark it without that stuff, then at least you can say to your IT team, can we for 5 hours turn this off? Because it will make our process go from 20 hours down to something reasonable. You know, those are the kind of discussions you can have with your wider teams. And it's still, again, it may not be something realistic or possible. And yeah, so again, like we always try to say, get that FME close to the data. It kind of goes in line with letting the database do your work. Let that database process that data locally, put it out into a format locally where FME can then maybe pull it out and then transfer it to somewhere else and do some additional processing and then move it to the final resting place. All right. Okay, so this next demo here, we're just going to really, you know, the goal was to maximize performance using the FME platform. The key thing here that as you dive into these, like, do you understand all of your systems? It can be a massive block if you're the FME person, but you don't understand databases, or you don't understand how the network's working, or what might be the system administrators or network administrators are actually running on your systems, slowing things down for you that you're not even aware of. So bringing those teams together is going to really make a difference. And so also, you know, your job may be to move data, but understand what you can change, what you have control over in your workflow. And that is where you really start to see these massive gains. So I'm over here. We got the screen coming up. So I kicked this off just a few minutes ago, well, at 8:08. And let's just refresh it here to see what's happening. This is what's happening on this server right now as an example. Now I'm just going to flip to the automation. This is the automation. And this is really taking what Trent's workspaces were showing. We're reading some data and writing some data to Snowflake. So in this case here, all we're doing is we've kind of done some magic to the data to be able to pull it out with FME much quickly. So this first workflow is really just one workspace that triggers and runs, and that's the parent workspace. Basically, it's looking at the data and saying, oh yeah, okay, I got this many groups of data that I can separate this out into this many jobs. And then it passes it to the child job. And this child job, all it's doing, and Trent's going to look at these workspaces in more detail a little bit later, all that's doing is kicking off a whole bunch of child jobs. So if I come back to my jobs, whoops, that's my engines. I've got a whole bunch of queued jobs here that are waiting to run. And then my running jobs, I've got full utilization of all the engines. In this case, I have 10 engines running on this environment. And then, you know, this environment does look like this. I'm not sure why my engines are not being utilized on my distributed engine host right now, but I'll look into that another time. But this is the flavor of FME flow that we have here. And you can see the different colors of our engines. These dynamic engines or CPU engines are very useful in these kind of workflows because you pay for the CPU usage. You don't pay for the full license outright like you would for a standard engine. Okay, and then, yeah, what else did I want to show there? Here's another server that we were using in this workflow. This is the one that trumped the best, and that's simply because it was very close to the data, the Oracle data that was pulling out. Again, it was 16-core machine. We had 14 engines running on here to do the processing. So I'm going to stop sharing. We'll go back to the presentation. Let's bring it home here. These are the automations. These are the workspaces that Trent had created in the desktop and published them to the flow environment. And what we found, very interestingly, just moving them up to the same Oracle database, FME in the West Coast now, because Trent's in the East, I'm in the West, and then running 15 engines on one system, 2 hours and 48 minutes. Make a note here that I'm hogging my CPU, okay? I've got 15 engines and only 8 CPUs, so I'm being a bad boy there. I'm not really following the rule of 1 CPU per engine. But you can see that we've got that 50 million. Now, in Trent's case, he was moving 150 million each time, and we'll come to an example of that. But we were able to move that in 2 hours and 48 minutes. So then I was like, well, what can we do at the database to maybe help us get this data out faster? So I was thinking, well, right now it's hard to juice up this data and get it separated across all these engines. So let's do that. Let's create a group ID, a virtual group ID based on the row num, separate the data out based on the number of rows in the table. We came out with, I don't know, 100 jobs to process, 500,000 records per job. And so we tried that with just the view and the group ID, a virtual ID on the back-end table. And that, well, we got 20 engines thrown at it this time, 10 engines on each system, still using my CPUs a bit. I got 2 hours and 27 minutes out of it. So then we're like, well, what else can we do? So I said, well, maybe we'll try a materialized view. Now, maybe this works for some people's workflows, but it's a very powerful way of making the data look the way you need it at the database. And it also allowed me to create an index on that column. Now, keep in mind, the original data didn't have any real easy way to group the data so I could subset it and break it out. So we did this and we just tried it for fun. One system, 10 engines, 8 CPUs again. So keep in mind, less engines than the rest of the systems, 2 hours and 30 minutes. So we're in this ballpark with half the engines that we did in the previous modification of the data. So then we took it a step further. Like, what else can we do? Well, we can move FME closer to the database. So we did that, thinking, well, maybe we'll get it down to an hour. And lo and behold, we were able to pull the data out of the database so much faster and reduce the network latency between those environments, and realize that that's where the biggest bottleneck was the network between the database and the FME. And we did it in 21 minutes with a properly sized server running 14 engines with 16 CPUs, 64 gigs of RAM, not really touched. And that's kind of what we got through with 50 million records. And then we did another test. We just said, well, let's go back to the West Coast. Let's move the data to a West Coast RDS system in Oracle. We did that for fun, 20 engines. Again, not being nice to the CPU counts, hour and a half. We got it done. So then we threw the whole data set that Trent was working at with it, and we were able to get it done in an hour and 5 minutes. That's 150 million records from system through FME into the Snowflake database on the end. All right, Trent. So I guess that's back to you and I here now to talk a little bit about best practices.
Yep.
Anything to add on that stuff that I just went through?
Not really. No. I think the only thing I will add is before we had moved it to FME Flow, and I had just run it on my machine with a workspace runner where I'm limited to essentially running 7 child jobs at one time. I was able to do it, and it was like 4 hours and 50 minutes or approximately like that. So 4 hours and 50 minutes down to just over an hour is a pretty sizable gain for reading, for going from database to database.
Yeah. And your environment was your VM, was that your local machine on your at home, or were you on?
Correct. Yeah, just my local machine.
Yeah. So you're in Toronto and the database is still in Virginia, right? So
Yep.
So okay. So
moving on to some key recommendations for effectively managing and scaling your big data workflows. Think of the data medium. So if you can avoid writing large amounts of data, if it's inserts, for example, to the database, and you can use an external or a third-party file format like CSV or Parquet, I caution you to consider doing so, because that will be drastically improved for performance. Or something as simple as thinking about is the data compressed versus non-compressed if you are using CSV files as an example, because this will considerably lessen the network load that is required by the database. Break up the workflow. You don't have to have a single workspace that does all solves your entire problem all at once. Breaking up the workspace could be subsetting the data that you're reading, could be subsetting the data that you're writing, could be using a materialized view or indexing a column. In our case, indexing the column that we were using for the group IDs gave us approximately about a increased our performance by about 20 times. I think originally we were getting about, I think it was like a 5-minute query time for just getting the individual groups, and we got that down to, I think it was like 20 seconds.
That's right.
So,
Yeah.
so something as simple as a index on a column can drastically improve performance. And then leveraging the flow and the CPU engines can drastically improve your process times. But don't think that more engines automatically will improve performance. You really have to consider the network topology, and what I mean from that is the IT standpoint, not the GIS. So your network architecture, the network latency. And then lastly, are there other optimizations? Consider the task and the environment that you're working with and act accordingly. So, are there bandwidth stealers on your network? Is the database, competing for resources? What are your specific needs? How fast does this migration need to run? Is it something that needs to occur daily? Is it weekly? Is it quarterly? And those are, those are just some examples. Because different constraints are going to have different acceptable durations and things like that. And then, you can always make some temporary changes to your VM, to the VM resources. Could be adding more CPU, add more RAM. Just don't be happy with the status quo. Anything to add on there, Steve?
No, I think you got that nailed for us. Yeah. Next slide there.
So some data processing and transformation tips. So we've touched on the data delivery method. You can, by all means, you can write directly to the database or pull data directly from the database. But with your given workflow, can you make use of the database's native tools for importing or exporting to different data options, such as CSV or Parquet? Can you simplify the data? If you're making some updates, you don't need to read the entire data set, or you don't need to rewrite the entire data set. If you only have 100 updates, but you have a table of 100 million records, it doesn't make sense to write all 100 million features again. So can you consider doing a cheaper pull of the network in terms of grabbing less data or writing less data? Because that will be drastically better performance than having to read or write the entire data set and then discarding what you don't want. You can reduce on-the-fly transformations in the workspace by transforming the data at the source within the database's built-in tools. You could do change some date formats. You can do reprojections. You can do schema mapping if you're doing materialized views on the fly. And then lastly, consider the behavior of the workspace. Is it CPU intensive? Is it RAM intensive? Is it disk write intensive? And then alter your VM or your machine if you can accordingly. Don't just focus on FME. Ensure you're considering all systems that come into play and reviewing real-time stats while the job is running. Because in our case, we thought FME when originally running and we were getting the 2.5 hours, we thought FME might be the slowdown. But then it appeared to be an actual network and database issue that we once addressed drastically improved the performance. That's right. Anything to add, Steve?
No, that's good. Yeah, it's really all of these things are just things that kind of open up your toolbox of things to look into, and I hope that's what it's doing, because it sure was a fun exploratory for us as well.
And then, so moving on to some more performance optimization techniques that most likely would be specific to these cloud native databases is, again, this should be the tagline for the webinar, is leverage the database. So the native database tools will be far more optimized to handle large data volumes when it comes to both reading and writing. Know the database architecture and best practices will go a long way in allowing you to improve your performance when it comes to these FME workflows that are working with these cloud native databases. Reading. Something as simple as reading there's a lot that you can do to optimize performance. We've touched on, creating a new view, creating a materialized view, using indexes. Something as simple as a where clause can get you the data that you want and pull it, faster than just reading all the data at once using a generic database reader. And then the FME flow architecture. So more engines doesn't mean faster processing time. You really need to find the balance for your system. If you have 12 CPU and you throw 30 engines at it, performance could be hindered as engines will fight for that CPU time. scale engines in that virtual world. We recommend one engine per CPU. Anything to touch on there, Steve?
Nope,
On the
that's
flow
good.
side?
Yeah,
Okay.
that's all good.
Okay, now we're going to jump out, and we're actually going to step through that workspace that Steve touched on earlier with the flow side. So it's going to be an Oracle Cloud to Snowflake, rating approximately 150 million features. And in my case, the whole idea that I wanted to try was, getting outside the box. So not just using a generic Oracle reader and writing to Snowflake using the Snowflake writer. I wanted to kind of leverage those databases to improve performance and get it writing as fast as possible. So I'm going to share my screen, and I'll have to do it twice. Okay, so here's the first one. So this first one here. So this was essentially the first workspace that was shown, or the first job that was shown in the automation. And what is occurring here is all I'm doing is grabbing the unique group IDs from my Oracle Cloud table, and that is using that view that we had created, that materialized view. And that is passing it to an automation writer. And what that's going to do is that just allows the group ID attribute, or the value, to be passed through to the next workspace that is going to be kicked off down the automation. I'll have to reshare my screen now. And we'll actually step through the child workspace of what is being kicked off by all those different engines that we saw earlier that Steve showed.
Yeah. Yeah, and one thing that came out for me was like, it's not always practical to create a materialized view on big data. It may and may not be, but, regenerating that materialized view, it took, I don't know, 20, 40 minutes. We were using a single CPU Oracle database. So I know on the Oracle database side, and keep in mind the 600 megabits bandwidth for the network card. This process here, I know we could have got even faster pulling from the Oracle database out and improved it, but we never bothered scaling the environment. That might be some testing we'll play with down the road. But again, we know that that part of the environment or the workflow could have been improved upon greatly.
So here's the child workspace that was kicked off by those group IDs. This beginning pass is just where the group ID is passed in from the parent workspace. Then we're just doing a simple select statement based on the group ID. We just do a little bit of attribute cleanup. I am then writing to CSVs, and those are compressed as a GZ. I then just fix up the file path, pass those directly to the S3, which uploads it. And then we use Snowflake's native tools to import from that S3 bucket directly into the table from the CSV. And that's where we were able to get it down all 150 million records. So I think in our case, I want to say it was 100 jobs that each took approximately 3 minutes, I think it was.
Yeah, when we got it down to even the big data set, it was taking about the 150 million. We were able to get it down to running that child job in about 3 minutes, down from 15 to 25 minutes as the environments were fighting and thrashing about. It made a massive difference. Yeah.
And just to be clear, that was each job. So if we were running 10 jobs at a single time, each job was taking 3 minutes max. So we were getting 10 jobs done per 3 minutes.
Yeah, that's right. Well, 14 jobs in the final test I did 14 jobs at a time. But again, think about it. We could have distributed the engines onto another system, and we could have been doing 20 jobs, could have been maybe even doing 30 jobs, depending on how much we wanted to scale it. So, and again, back to the database where we're pulling the data from, that was the biggest chunk of time. If we could have increased the bandwidth even out of that database from 600 to even a gig, if we could have gave it more CPUs on that database to deal with the sessions we were creating to the database, all of that, I think we could have, I don't know what we could have got it down to, but I think we could have improved it some more. Yeah.
So to conclude, the kind of the thing that we'd like you to walk away with is, be creative when it comes to moving big data and working with cloud native databases within FME. We've touched on using the native database tools that are supported by your database to really leverage it and get the most amount of performance out of your workflows. So really, think outside the box. Don't be happy with the status quo, if you will.
Yeah, and really, it just comes back to being able to pull in those other resources that you may not be the expertise in, but from this webinar now, the different parts of the pie that you may have to involve, I hope, to talk to pick their brains on, to see if there's things they can help you with. So, all right, we're wrapping up here
some
now,
resources
Trent.
here. So we've got a tutorial here, and then a previous let your database do the work webinar as well. That might be good resources to just to think about what can the database do that maybe you're not considering currently. We have an ebook that if you'd like to register for or sign up for. Then we have the FME Academy. We have knowledge base and webinars. And a copy of these slides will be sent out, so you don't have to write these links down. And then some next steps. So, if you have any questions, feel free to reach out. If you're still new to FME, consider the accelerator. It's a good way for, really ramping up in 90 minutes or so. And then, we hope to see you in Germany. And I think that's next week. Man, time flies for our new user conference for this year.
Sure does. We won't be there though, Trent. Sorry.
No, we will not.
All our fans.
Don't forget to claim your community badge. And then we'll jump over to QA now.
Lovely. Okay, so I'll get our presenters to turn back on our webcams and we can take a look through the questions panel there. Thanks, Nampreet, for holding down the fort. Lots of great questions.
Yeah, we've got a lot of good questions here for sure. I can field some that kind of piqued my interest, and we might be good to discuss as a group here. First one here is, can database triggers slow down upstart processes? So things like tracking changes and stuff like that.
100%. Yeah, Yeah, 100%. Triggers can create overhead. And so it's wise to be aware of them. You may need them depending on your workflow, but when you're dealing with big data, is there another way you can get that behavior firing instead of using triggers, right? So, but definitely, depending on what the triggers are doing, tracking, writing to an additional table, those things are gonna take time. Yeah, committing records to a database. Good question.
Great. A couple of questions around the CSV formats. One was, what CSV format do you prefer? And I think this is more on the encoding side, so like the MS-DOS versus UTF-8. Have you guys looked at that at all? Or any advice there?
Yeah, I have not looked at that at all. Yeah, that's weird. I've not even thought about the encoding of the CSV files, so I'm just trying to context this a little bit.
One great tip that you guys provided, which we might want to emphasize, is the compression of the CSVs. I thought that was a great little tip there.
Yeah, really look at the database documentation, because it will really outline what they're expecting from both what they will produce, if they do support exporting to a CSV or another file format, and then same with the import side, of what they're expecting. I will say the biggest thing for, especially at least on the import side, is it really needs to match the structure of the database. Like, you can't just have a couple of the columns. I believe it, it basically needs to represent what exactly is in the database.
Yeah, 100%. And that's just right. How do you keep formats from changing as data is added to your source? So I'm not sure if I think about the database structure in that context, I'm thinking about tables changing. Absolutely. FME one day will read 10 columns and create a CSV file for you and do something with it. But if you're not considering what that is going to do to your target system, then you're going to have a broken environment or broken workflow. But yeah, we have things like the schema there's some schema reading we can do a little bit more now that can help understand if there's been a change to the schema. I don't know if you played with any of the schema outputs from like the SQL Creator now has that data and schema or just schema that you can get out of there. And whether you can do some validations to check that if the database has changed on you from the last run. I haven't played with that myself, but.
Yeah, that's a super useful thing to incorporate in your workspaces for sure. I've kind of dabbled in that myself here and there. Yeah. Just on the same line of CSVs, I took a stab at answering this, but it'd be good to get your thoughts. CSV files often do not contain database structure. How do you keep formats from changing as data is added to your source data? So my thoughts here were more around ensuring that your tables are created, the data model structure is created in the database prior to some of these processes involving FME being set up, so that you don't have to worry about kind of data structure. But just would be great to get your take on this question as well.
Yeah. So that question I was looking at before when I was trying to wrap my head around the question you were asking. So I apologize for that confusion. Yeah, that's an interesting thought. Yeah.
And I know like Parquet is an alternative to CSV, which supports some database structure info, or has that support there. But I'm not sure if all platforms support Parquet.
Yeah, I think ideally in any kind of big data movement or even, you know, smaller data movements, the idea of using FME to create the new schema for you is something that, you know, a lot of users like to have the power of doing that, right? But in some cases, it does get challenging. FME does some interesting interrogation of the data it's reading. So if you're leaving it to a dynamic kind of thing and you're not driving the attribution that's being created, or it's not already pre-created, you can get some funny business going on it when the data is changing. So for example, I think there's some instances where we scan the first 100 rows of data to determine if it's a varchar or to determine if it's you know, a number or whatever it is. And that kind of behavior can change if your data coming in is changing on you, and you may get a different output trying to create a table in this target database that's not what you want. So, you know, I've got some customers that have very rich understanding of the database they're reading from. They validate the data structure. They make sure there's been no changes. And if there has been changes, then they actually will change scripts that are then being called by SQL executors to create tables ahead of time. And they'll make the changes in those external files that FME will use to create the tables before loading the data into. So it's kind of an interesting way of tracking, you know, finding out there's a problem, making a change, and letting the workflow run then. Yeah.
Awesome. All right. And before we wrap up here, team, I know we just have a minute here left before the hour. Is there any other questions that we would want to address live? It looks like we would have time for one more, if so.
I think there's one more from Lynn here. You can post it here. Will the database readers and writers be optimized in the future so S3 bucket isn't needed?
That's a good one. So you mean you basically incorporate an S3 bucket setting in the FME options. Use this bucket when you're loading data. It's actually an interesting idea. Has it been created in the community? That would be kind of nice. Yeah. Kind of be like using your local Dropbox or online drive, Microsoft Drive to put data into, and then someone else is pulling it from somewhere else. After it syncs. I like it.
All right, with that, I know we are at the hour, so I just want to say a huge thank you to our presenters, Trent and Steve, for all your work on this webinar today and over the past couple months. And thank you to Nampreet as well for joining us on Q&A and for content development. So please, if you do have time to fill out our webinar survey, we appreciate any feedback. It's just a few multiple choice questions. I posted the link in the chat there. And thank you so much to our whole audience for joining us today. We really appreciate it. And we hope you got a lot of value out of this webinar.
Thank you very much. And we're always looking for ways to improve and feedback. So please don't be shy and let us know anything we can do for you. Thanks for joining us today.
Thanks, everyone. Bye for now.